Hi, and welcome to another Radan technical video. This month's video looks at the options and settings for Radan's common line cutting feature. Common line cutting is the process of cutting two different part edges simultaneously with one cut. This type of cutting is defined by setting the nester to place such parts in the nest so that the gaps between them are equal to the kerf width, instead of using the normal nest spacing for parts. This means that when automatic tooling is applied to the nest, it will be able to create common line cuts between those parts. For profiling machines, when using true shape nesting, you can specify that a part is suitable for common line cutting by setting the common cutting control when you add the part to the nest schedule. The control will be set by default if the part's common cutting attribute is already set. For each part, the following choices are provided for the common cutting properties. None means part will not be nested for common line cutting. Unrestricted means the common line cutting can happen between any two parts, whether the parts are the same shape or not, if the unrestricted method is set for both of them. And the same part setting means the common line cutting can happen between any two instances of the same part, but not with any other part definition in the schedule. A common cut group is a group of parts in a nest that are all separated from each other by the kerf width. The common cutting method you choose controls the form of common cut groups that the nester creates. If you allow some parts to use the unrestricted method, common cut groups can potentially contain any combination of those parts. If you specify the same part method, common cut groups will be created that consist of that kind of part only. When using the same part method, you may limit the number of instances of that part that may occur in any one common cut group. Use the maximum CC group control when you add the part to the parts list. For example, if you set the maximum to 2 parts, the nester will nest the part in pairs with a single common cut between the members of each pair. If you set the maximum to a number greater than 2, the nester will create compact groups in which the parts are arranged in a rectangular pattern. Let's generate a nest in Radan using parts with common line cutting. Starting with this active nest project, we'll add a few parts. For the first part, where only 4 are required, same part is the common line cut setting, and the max CC group is set to 2. So the 4 parts should get paired up. The next part is small and does not have a shape or size appropriate for common line cutting, so the common cutting setting is set to none. For the other large part, 12 are required. The common cut setting is set to same part, and we'll set the max CC group to 6 parts. Because more than 6 are required, the nester should make 2 or more groups of this part. Within nest projects, you can control what nest schedule info is displayed, including common cut and max cut group settings. Simply right-click on the column header, pick Choose Columns, and select the nest schedule properties you want to track through the window. When the nest is run, you can see 4 occurrences of the first large part added to the schedule where the max CC group was set to 2 ended up in pairs, with the longest straight edge used as the common cut edge, and the other larger part that also had common line cutting set has a max CC group of 6, so the nester created 2 groups of 6 each in this instance. As mentioned earlier, the common line cut control can be set by default if the part's common cutting attribute is set appropriately. In essence, presetting the common line cutting settings before nesting. For each part, the same 3 choices of none, unrestricted, or same part are provided for the common cutting attribute property, And the maximum common line cut group number can also be saved as a part attribute. Here is how the common line cutting attributes can be set with parts. To set common line cut attributes in a part, just access the Part Properties dialog for the part and pick the Attributes button. Then scroll to the Common Cut Attributes located in the Manufacturing Attributes section. Attribute 145 is the common cutting attribute, and it has a pull-down list with the 3 common cut options. Just below that attribute in the list is the attribute for the maximum common cut group, and you can enter the maximum number of parts per common cut group for the part. With those attributes preset in this part, when it is added to any nest schedule now, the common cut setting and maximum common cut group size will default to the preset values. There is a system setting for controlling the order of cutting for common line cut parts in a nest. This system setting is accessed through the Machine Configuration Editor's Advanced Machine Settings by entering AO4-B in the key field. When set to N or No, the holes for all common cut parts are cut at once. If set to Y or Yes, holes are cut for each part in order just prior to cutting out the part's external profile, referred to as part order cutting. Let's review this setting within Radan. This setting within the Machine Configuration Editor is described in the dialog as Cut Common Cut Parts in Order and is currently set to No. So for the same nest where we now know which parts are being cut with common line cutting, we'll auto-order the nest and recompile. Notice how the holes in the parts that will be common line cut are being cut all at once instead of just per part. Also notice that the small part that is not common line cut is cutting in typical part order where the holes for each part are cut, then the outsides of the small parts. The last things cut in the nest are the external profiles for the common cut parts once all the holes for all the common cut parts are cut and any other parts in the nest. When the setting AO4-B is set to Yes and the nest re-auto-ordered and the code recompiled, you'll notice in the verification that the cutting order for the same nest is different. The holes in the parts that are common line cut are cut in part order. So each part's holes are cut, then its outside profile. Then the holes in the next part are cut and its outside profile, and so on. The reason for using common line cutting is that it can reduce the time taken to cut the nest and reduce the consumption of energy and consumables by the machine tool. So in Radan nest parts that have the common cutting property, the nester tries to produce as much common cutting as it can. In other words, the nester tries to minimize the total length of cuts needed to cut the parts from the sheet, and so minimize the cutting time of the nest. This is why common cut groups tend to be compact blocks of parts, which are often roughly rectangular like those shown in the demo. It is important to understand that the aim of minimizing the cutting time conflicts to some extent with achieving the best material utilization. A compromise between these two objectives will need to be made because the best nest for one is not often so good for the other. This fact surprises some because nesting the parts close together might be thought to reduce wastage. Actually, that effect is small and is often outweighed by other factors. You may sometimes notice that the compact groups of parts that produce the greatest amount of common line cutting might not maximize material utilization of the nest. It is recommended that you select common line cutting for those parts that will benefit from it the most. Some parts will not be able to produce very much common line cutting because their shapes are just not suitable. If you instruct the nester to nest such parts with common line cutting, then it will do so, but the nest's materialization might be seriously reduced while only reducing cutting time by a small amount. Common line cutting is most effective with parts that have simple shapes with long straight edges, such as squares, rectangles, or similar shapes. Nesting such parts with the same part method will often produce tightly packed groups with a large amount of common cutting in them. Moreover, the common cuts that are created when auto-tooling is applied to the nest tend to be simplest in form when the parts have that kind of shape. In summary, we've seen that common line cutting can reduce cutting time and may improve materialization. The common line cutting setting can be set for each part as it is added to the nest schedule, or be preset by way of its common line cutting attributes. And the setting A04-B controls the order of cuts for common line cut parts. Thanks for watching this tech video, and stay tuned for more videos from the Radan Resource newsletter.